In this video, we'll cover 7 Chapter 23 exercises, and as with other exercises like this, you may want to first see the question, answer it on your own, pause the video, answer the question on your own, and then see the answer that I have provided. First question, a ring that results from the following reaction contains, so if you look carefully at it, you would recognize that this is one variation of Robinson annulation, so reaction of carbonyl compounds, inlet anion with alpha-beta unsaturated ketone. So it's Robinson annulation, and Robinson annulation is method to prepare 6-membered rings. And those 6-membered rings contain carbonyl group and a double bond actually. Carbonyl group and a double bond. So answer A is actually incomplete because a product does contain 6 carbons and carbonyl group, but there is also double bond present. B and D are wrong because rings is 6-membered, not 5-membered. So C is complete answer. Product contains 6 carbons, carbonyl group, and a double bond. And you can see here from the reaction mechanism, formation of inlet anion, addition to beta carbon of alpha-beta unsaturated ketone, formation of intermediate inlet anion, and then isomerization of that inlet anion into alternative inlet anion, closing of the 6-membered ring, and since the reaction is carried out with heating, elimination of water to give the final product 6-membered ring that contains carbonyl group and a double bond. Next question, what is the product of this mixed Glacier condensation? We have an excess of ester that is aromatic, so it cannot be enolized. It does not form inlet anion. That means inlet anion will form only from the other ester shown on the right, methyl acetate. And addition of inlet anion from methyl acetate to carbonyl group of this methyl naphthanoate will result in formation of carbon-carbon bond and loss of methoxy group, leaving group. And that gives ketoester as the product. And in fact, if you know that the result of mixed Glacier condensation is beta ketoester, there is only one beta ketoester here, and that's A. Question number 3, what is the product of the following reaction? So you can see nitrile ester. Nitrile ester contains CH2 group, methylene group that is activated by 2 groups, nitrile group and ester group, which means it's acidic and can be easily converted to carb anion, to inlet anion. And then as the other reactant above the arrow, you can see methyl vinyl ketone, and therefore this reaction is Michael addition. And to figure out product of Michael addition, you consider the bond that will be formed between inlet anion, so carbon of the inlet anion, and beta carbon of the alpha-beta unsaturated ester. It's shown here as dashed bond, and product, of course, of that reaction is compound C. As an exercise, you may want to write down the entire mechanism. Question number 4, what is the product of the following aldol condensation? We have aldehyde and then aldol condensation. That means that reaction is aldol reaction followed by dehydration, and product is alpha-beta unsaturated aldehyde. So product of an aldol condensation is always alpha-beta unsaturated aldehyde. When that is the case, when certain class of compounds is product of particular reaction, as we have seen before, beta ketoester is always product of Glacier condensation. In this case, we have alpha-beta unsaturated aldehyde, product of aldol condensation. Then first among the 4 possible answers, you should check if there is only one answer that represents that class of compounds, because then that must be correct answer. If other answers represent other different classes of compounds that cannot be produced in this kind of reaction, in this case aldol condensation, those are obviously wrong answers. And if we had 2 or 3 alpha-beta saturated aldehydes, then those would be possible answers, and you could eliminate remaining answers. But in this case, we have only 1 alpha-beta unsaturated aldehyde, and that must be the correct answer. Of course, as a practice, you should write down the mechanism and convince yourself that this is indeed the product. But on a test, when you're pressed for time, then you may want to apply a shortcut like that. If you know which class of compounds is the product, then you look at if there is only 1 compound of the 4 possible choices that belongs to that class of compounds. If that is the case, then that must be the correct answer. Question number 5. What is the product of the following reaction? And hopefully you can recognize this reaction as a Glacier condensation. So it's reaction of ester, Glacier condensation of an ester, and Glacier condensation again gives beta ketoester, and only B is beta ketoester, so that's the correct answer. Again, as an exercise, you should write down the mechanism and convince yourself that this is indeed the answer. Question number 6. How many carbon atoms are in the ring produced by a base-induced cyclization of 2,7-octadione? So you start by writing down 2,7-octadione, and then of course cyclize it, and you can see that there are 5 carbons in the ring. And since there are 5 carbons in the ring, this cyclization will be accompanied by elimination of water, spontaneous elimination of water, to give, in this case, alpha-beta unsaturated ketone. So to figure out how many carbons are in the ring, you simply generate 1 enolate anion, and then see how many carbons are between that enolate anion and the other carbonyl group. In this case, there are 2 possible enolate anions, and one would close 7-membered ring, the other one 5-membered ring. And hopefully you remember from lectures that when there is competition between 5 and 7-membered rings, 5-membered ring forms, because probability of closing 5-membered ring is much higher compared to probability of closing a 7-membered ring. So in reactions like these, cyclizations of diketones, 5- and 6-membered rings are preferentially closed or formed. And finally, question 7. Provide formula of the product of the following reaction. We have ketone, phenone, acetophenone, and reaction with bromine under acidic conditions. That's bromination of a ketone. Bromination occurs, halogenation, bromination occurs alpha to the carbonyl group, and since reaction occurs under acidic conditions, only monobromination occurs. Sorry, this shows 5-membered ring. Now only monobromination occurs, and so product is bromoacetophenone. And this completes chapter 23 exercises.